So that's the quick and dirty method. It's pretty simple, but it's not the most accurate. So how do we get more accurate? Well, we use the more accurate method. For this example, you're again going to start by sorting your data in ascending order. Next, you will find the position of each quartile using this equation. For example, the position of the first quartile is count, or the number of values in our data set, which is 10, plus 1 times q divided by 4, or the quartile we are trying to find, which is 1 divided by 4. And when we solve all of that out, we get 2.75 as the position. Now we just need to look back and see which number is at the position 2.75. But there is no 2.75. We only have whole numbers here. So how do we calculate this? You can think about it like this. 2.75 is 75% between 2 and 3, right? It would be about here on a number line, 75% between these two numbers. So what number is 75% between 8.25 and 10.98? So what number is about here on a number line? There's a few different ways that you could calculate this. I found the difference of these two numbers. Then I found 75% of this difference. Then I added that value to 8.25, right? So 10.3 is about 75% between 8.25 and 10.98. So this is my first quartile. Using the same method, I calculated my second and third quartiles. The good news is you're probably not going to need to calculate quartiles by hand. You just need to know how to explain them if you choose to include them in a report. So what code do you use to calculate quartiles for you? In Excel, you can just use the quartile formula. In Postgres, you can use this code. And in Python, you can use the percentile function within the NumPy package. So I hope this helped, and follow for more.